negative externality is a cost that spills over to third parties. Who's the third party? When we're talking about supply and demand, the demanders are the first party, they're the buyer. The sellers are the second party, right? A third party is an innocent bystander who is not necessarily one of the people who is buying the product or selling the product. And a negative externality is a cost that spills over to these third parties, and they're not really otherwise involved, right? So a negative externality or a cost externality is a cost that spills over to third parties. Now, what we're concerned about as economists when we're thinking about supply and demand and the possibility of externalities is we want to look at the total surplus created in the market. And total surplus is just the difference between the demand, which tells the value for each unit that's being produced, and the supply, which is the cost of producing each unit. And the total surplus is just the sum of all of those differences between the value minus cost, value minus cost, value minus cost, value minus cost. And when we add all those up, we get the area of this yellow triangle here, and we call that the total surplus. Now in this case, the total surplus appears to be 1/2 times the base here, which is 15, times the height, which is 5. And that total surplus, that area, is 37.5. And let's think about this in terms of millions of units. So this would be $37.5 million. And that's a good thing because we've taken the value of the product minus the costs of the product. So the value minus the costs. And there's a difference between 37.5 million. Now, what is the problem? Well, we just said that we're going to look at a case here where there's another cost that is not being captured yet by this graph. So let's add that in. When we look at the cost down here that I was just talking about, what makes up those costs, the sum of the marginal costs over here, are things like labor and materials. So they're the things that cost a business more when they produce more units. Now, in this case, though, what we're going to be focusing on is the idea that these marginal costs are only the private marginal costs, the ones that are the cost to the business itself. And these costs that are represented by this blue line do not include the external cost. So let's talk about a particular example of an external cost, pollution. So a cost that very commonly spills over to people who aren't the buyers and they aren't the sellers, that just gets passed on to other people in society, would be a pollution cost. Could be air pollution causing lung damage or respiratory failure. Could be water pollution. So when we look at the costs here on this supply curve, the cost here of $4 would represent the labor and material costs. We call them the marginal costs or the variable costs of a business. And the cost here for the second unit is $5. The costs, these are labor and materials costs for the third unit, are $6, and so on. But this doesn't include the cost of the pollution. So let's add in a pollution cost here. Let's suppose that for every unit that this producer makes, every unit of this good that is produced, that there is an external cost of $3 per unit. Let me not use the little fuzzy pencil tool there. Let me use the pen. So cost of $3 per unit that is an external cost. And let's assume this is a cost that the business imposes on the rest of society by dumping some pollution into the river located next to the factory. So it looks at first glance, if we don't look too carefully, that we have a total surplus of 37.5 million. But this is actually wrong, because the total surplus implies that we have taken the value of what's being created and we subtracted off the costs. But we haven't done that. We haven't subtracted off all the costs, at least. We've only subtracted off part of the costs. So if there's a $3 per unit external cost or pollution cost, in order to analyze what's going on here properly, what we want to do is take the costs on the supply curve here and add $3 to it. So instead of just the labor and materials cost being $4 for the first unit, we want to add 1, 2, 3. That's the true cost. That's what we call the social marginal cost. Social marginal cost. It's going to include the private marginal cost plus any other external costs like pollution that get added in here. So we want to add $3 here. So that's 5 plus 1, 2, 3 takes us to 8, etc. And we're just going to do that for every point. And really, in the end, what's going to happen is instead of the y-intercept of this supply curve being 3, it's going to move up to 6. So let's sketch out what this supply curve is going to look like here. Not technically a supply curve, but the social marginal cost curve. We're shifting the supply curve up by the amount of the externality. So instead of our equilibrium being here at point A, that's what the market would do. What society should prefer is that we stop producing this good at point B. Because if we have a good that every time it's produced creates pollution, we would want less of that to be produced, right? And what we want to do is produce the amount where it's the best amount, the right amount, assuming we're actually taking all of the costs into account. And that's what we're doing here at point B. We're taking those external costs into account when we're doing this analysis. So what that suggests is that instead of 5 units being the quantity of, or 5 million units of this good, we would only want to produce 4 million units of this good at point B. And in order to do that, maybe the price of the product ought to be higher to take into account all of the costs of producing this product. Okay, well, how can we analyze what's going on here using some numbers? Well, first, let's take a look at that total surplus of 37.5 million, which I said it's not really surplus, and let me demonstrate why that's not really surplus. The real amount of surplus we're going to get at point A, right, is 37.5 million. That's kind of what it looks like at first, but minus, we'd have to subtract off $3 per unit for the pollution that's being caused, right? And at point A, we're producing 5 units of this good, so 5 times 3, we'd have to subtract off $15 million worth of pollution that's being poured onto society. And so there we're going to be only left with, let's see, 37.5 minus 15 gives us 22.5. So our real surplus would only be 22.5 million. All right, so that's what I'll call the real surplus. And then the question becomes, can we do any better than $22.5 million in real surplus? Absolutely we can. By stopping production at point B, this becomes our real surplus if we can stop producing at 4 units instead of at 5 units. So how much is this surplus if we don't actually make 5 units and we stop at making 4 units? Our real surplus is going to be 1/2 times the base here. Goes from 18 down to 6, so that's 12 times 4. And so our real surplus, that's better than the old overproduction kind of market-driven answer, is going to be 1/2 times 4 times 12 is 24. And so this is an improvement, getting a larger difference between the costs and the benefits created in a market. Hey, that improves things. So in this market, if we produce too much, we can visualize that this is creating a deadweight loss. Now, how much is this deadweight loss? Well, it's the fact that if we don't do anything, we're only going to get 22.5 million in real surplus. We could get 24 million. So anytime surplus is decreased due to an inefficiency in the market, we call that a deadweight loss. And we can see the deadweight loss here is the difference between those two, 24 and 22.5. $1.5 million in this case. Now to visualize that on the graph, there are a couple of different ways we can do it, but here's probably the easiest way to do it, is to say, look, if we keep producing from 4 to 5 million here, then for each of these goods we produce in this region, the cost is actually higher than the value. And we want to add up all of those little occasions where the cost is bigger than the value. And so the deadweight loss is going to be that triangle, the area of which is going to be 1.5. Let's verify that. The height of this triangle is going to be, well, here I actually think about this as being the base. It's going to be 1, 2, 3, right? 1, 2, 3. And then the height is going to be 1, just the distance between 4 and 5. So 1/2 times 1 times 3 equals that 1.5 million that we were talking about in deadweight loss. Deadweight loss is always the difference in total surplus that we could have compared to what we're actually getting in a suboptimal situation, right? So this is how you analyze a negative externality. To find what you should be doing, you can add the external cost into the marginal cost curve or the supply curve, find out what the optimal quantity should be here at B, and then see how much total surplus you're really getting, and then you can calculate this deadweight loss from overproduction. If you have any questions, please let me know. Otherwise, this is Berkey Academy signing off. Good luck with your studies, everybody.